For me, it's early morning. Where I am now is 7 o'clock. So thank you all for being here in this platform. And let's discuss the today topic in my speech, which is the advances in developing a framework for responsible and ethical AI. But I want somehow to connect also with the previous speaker about qualitative research. Qualitative research is very important for social sciences. For me, something that was not mentioned is that it's very important in education research. Of course, in any human interaction, we can have qualitative research in organizations for research about their status, about their people, but education, psychology, and marketing, I think are the most important. And of course, politics, what is the opinion of society about how society is moving forward. These are the most important areas for such research. It's my opinion, of course. So here we have, however, another paradigm, which is quantitative research. And quantitative research about AI. It's about responsible and ethical AI, but it's not only quantitative. My speech is about quantitative issues, but this research for responsible and ethical AI has to do also with qualitative research. It has to do with the interaction of technology and society, sustainability and technology, because without responsible and ethical systems, we cannot have sustainability in technology, and we cannot have, of course, sustainability in AI, in the AI paradigm. So let's talk about these issues in some detail, limited, of course, by my time. So it's quantitative, basically, the issue of AI. And everything is based on data. So the new gold is data nowadays. As we will see, and as we already know, the power of AI comes from computing power and many other facts that we will explain. But such a great power, of course, comes with great responsibility. So it's not only quantitative. I disagree seeing the things in technology only in a quantitative manner. And next topic is how to unveil learning machines in order to understand what they learn. This is a big part of responsible AI, as you will understand. And what are the actual messages coming from the analysis for responsible AI? So data first is the new gold, the today gold. And constantly, as you already know, every day we generate data. You will see numbers in the next transparency. Digital applications, therefore, are coming, and information systems are everywhere, and therefore data resources are everywhere. And all these companies, the big companies, and all organizations are based on this data. Therefore, we have a shift now. You know, in each country it happens. you know, the shift to digital economy. So we have a global digital economy nowadays. As I write here, it might be, it's not mine, it's in the literature actually. Data is the new oil, actually. It's treasure, and of course, there are also many issues in the management of data, because gold that is not mined is not gold. So we should mine the data, and you should understand, first of all, what we are talking about, what type of data we are talking about. See some numbers, there are many, but see some numbers regarding data. In total, we may have, this number, it was for 2022, 2023, is petabytes. Petabytes is produced every day in the world of Internet 3 years ago, 2022, now we are 3 years ago. Petabyte is a very big number. It's over terabytes, of course. Terabytes is something small. We can see that this is produced by only daily applications in short applications. You can see that terabytes are within connected cars only. In a small city, nothing. It's nothing. Petabytes is actually not all data, but all Facebook data. Remember, petabytes only for Facebook. We have 500, as you can see, million tweets per day in the Twitter. This was data, again, 4 years ago. We have 4 billion people exchanging emails every day, 4 billion. And this is the number of emails per day. You can see that the data for 2020 coming from wearable devices, it was 28 petabytes. So you may understand that the whole data now, for instance, for 2025 is 463, not peta, but e-bytes. It's and zettabytes. We are talking about very, very, very huge numbers. You cannot write easily the zettabytes in your paper. You need, let's say, 1 page to write numbers there. Zettabyte is something very, very immensely huge. And this is for every day. You understand, therefore, that the data exists as a treasure, but also as a headache, how to manage all these things. Here I have prepared from the literature a story about how the models evolved. How the models evolved from the dark era of 1940s, because this is the beginning of AI, through different machine learning models. I will not stay with this. Because of the Nobel laureate, I will stay with Hopfield Network in 1982, in backpropagation of Hedon 1974 to 1980, and then, as you can see, deep learning models Boltzmann's restricted Boltzmann machines, RNNs, LSTMs, deep belief networks, generalized adversarial networks, and nowadays capsule networks, and so on. Many models, especially for computer vision, and natural language processing. As you understand, the big things and this revolution starts early, as I told you, 1940s, but we have three milestones, three big events. 1997, the Big Blue with the chess blue machine, actually, the Deep Blue machine, was a champion in chess gaming and actually challenged the then days Garry Kasparov in famous gaming during 1997. In 2016, we see Google's DeepMind of AlphaGo, which again made very important progress in some gamings, but not only this, very important progress, as you can see only a pattern here, in medicine, when the true positives and true negatives were optimized and were better in certain kinds of MRI or other images than doctors, than experts. So this was a big progress, but you already know that the biggest progress that started the today revolution is during 2023, if I remember well. Okay, in 2023, we all started to know, but actually it started 2022. During, therefore, 2022-2023, we have the ChatGPT revolution, and now we have so many GPTs, generative pre-trained transformers, and generative AI, that is like a miracle. How many startups come day by day? So this about Google DeepMind, it was in 2020 in the Nature magazine, which is a model identifying cancer and superseding in mammograms experts' diagnosis. It was the first time that such a diagnostic performance of AI superseded human. But after this discussion, let's go to responsibility, because this is the main thing. Okay, in the beginning, we had the good times where we played with AI, and we played with algorithms, and these algorithms were based on human interaction. It was the humans that gave the inputs, not automatically. They processed very explicitly with also incorporated subdomain knowledge, etc. But nowadays, the paradigm is changed, not only to simple algorithms. Of course, we have algorithms. There is nothing more than algorithms. But here we have more advanced algorithms as MLOps, machine learning operations and deep learning operations, as programs and functions that really learn from data for data analytics, predictive analytics, and so on, optimizing performance. Of course, human interaction is needed, but now with such very complex architectures, it's very difficult to have understanding how systems perform, and therefore the complexity of models has increased the problem not only of understanding but also of management of such models. So the deep learning, although we are still in the beginning, as I believe, it's not needing as the not trivial, but the previous machine learning, which is still used, of course, every day. In order to, a parenthesis, machine learning is used in deep learning. The flat layer uses SVM or other models for training the deep learning models or the autoencoders. So machine learning is used actually every day in all deep learning models. But deep learning models can learn from raw data with few labels, and if you can see only a small symbolic model of the many layers involved in deep learning, you understand that this is something much different than the small machine learning models. It's almost impossible to understand the features that are learned in these very complex models. So transparency of any deep model is difficult. Actually, we are talking about black boxes. In a small backpropagation, it was easy to demonstrate what kind of features are in the hidden layers. Here, in deep learning, layer by layer, we go to sets of features, higher order features, of course, in the layers that are near to the output, and therefore it's very difficult to explore. So these are the major issues for responsible AI based on such an analysis. So responsible AI is a framework in order to have ethical, technical, in terms of explainability, as I will mention, and to be fully legal, because you understand, you have an autonomous car with deep models. Who is responsible for an accident? You know, accidents with Tesla and other models. Who is responsible there? We have legal issues. We cannot trust fully this technology. So the framework I mentioned from the beginning in this speech is about accountability. The framework for responsible AI includes accountability. Accountability, as you know very well from computer science and engineering, means to have a log, files, therefore, of any event happened in order to track everything happened in the system. This is a big thing for AI, but you understand it's difficult to mine information from terabytes of data, because terabytes of data exist in a deep model when it operates even in one day. Okay, I don't mean ChatGPT. We are talking about petabytes of log files, impossible to analyze easily. But accountability is very, very important for debugging. Engineers have to do a lot of work in petabytes. Interpretability. This is the most important issue for responsible AI. And I focus on this in the next transparencies. Fairness. Fairness, safety, and privacy. Safety and privacy, you understand. We have zettabytes of data all over the world, even every day. And so how we treat the private data? Because among the data in in all social networks, not in Facebook, in all social networks, we have also private data. It's messages, the SMS. Okay, you talk through cryptography, all messages are encrypted, but the messages are stored, of course, in the base stations, in the systems, emails, etc. You understand that privacy is something very important and for all our concepts. Safety, I already mentioned about autonomous cars. These systems should be safe in their applications, in any kind of application that is risky and may harm people or the environment or whatever. So safety and privacy, and also fairness to all. There should not be any discrimination, discriminative actions to anyone. So these are the cornerstones for a framework of responsible AI. I have to mention, because I will not have time to mention later, that we have three major acts now. First, the EU Act for AI, a big framework for responsible AI, not full, but they try. The people in Europe, they try to build such a framework. In USA, the USA Act for AI, and we have also IEEE Act. IEEE is the Electronics and Electrical Engineers of USA and all over the world organization. So we have three major acts trying to depict this framework in more details. It's actually a conceptual framework. This is what I'm saying about qualitative research, because this is not quantitative. These acts are qualitative research results and need a lot of improvement. Believe me, they are not complete. They are far from completeness, but it's a first step. As I told you, one of the major, maybe the major issue in these 5 cornerstones is interpretability. This is the reason I highlighted this more than others with boldface. Why interpretability? The issue is that the models should be able to provide explanations, or based on the data that the accountability, the humans should be able to extract information how the models do their jobs, how to test their reliability, validity, and so on. So interpretal machine learning is about extraction of any relevant information about what types of relationships the model has with the data, how it processes the data in patterns. So not numbers only, but patterns. something more than data. The higher the degree the interpretability, of course, the higher the trust and understanding of the predictive analytics of the models and all analytics of the models. And something else, if we want AI to be everywhere, applied everywhere, and helping humanity, we need to trust. And in order to trust, we need not unexpected things, not unpredictable things in behavior. We need explainability in everything, especially you understand in medicine. It's impossible to trust a model that you do not understand. So we need clear explanations and clear and the models to comply to conform fully to laws and policies. So it's not only the good performance, but also this issue of trust. And yes, we should care. In all the real-world applications, we should care about interpretability. Can we unveil from neural networks and deep neural networks, etc., what is learned or how they learned? We have three types of models in this explainer AI framework: the pre-model, the in-model, and the post-model. Pre-model means data analytics. It means to understand the data. Here we have data science, of course, and data engineering, exploratory data analysis, I would say. So before building the model, we need such analytics. In model, to see the patterns built in the model, and post-model, to interpret according to the results what is done there with the model. Not only what is built, but also how the outputs of the model behave on data. So for pre-model analysis, exploratory data analysis, we had unsupervised learning techniques that we know from statistics, like k-means clustering, k-nearest neighbors algorithm, and also prototypes and criticism model. Therefore, it's a generalization of the k-means and the other algorithm. So you can see the prototypes and the opponents, the criticism. So depending on the distances, of course, you can say that this is a good group, it's a prototype, this is another prototype, but these are criticisms. So not exactly outliers, it's an algorithm, the MMD critic framework. And you can see also the prototypes, clear prototypes, for instance, and criticisms with some differences, but they are still dogs, of course, as you can understand. So this is very critical to analyze, to understand the data. It's the first thing. The post-model has many models here. I will not explain because I will not have time, but the major algorithms are about decomposition, optimization, and deconvolution. Okay, here we have certain issues, mathematics, etc., algorithmic issues. It's impossible, of course, to stay to analysis of these post-model methodologies since this is a different advanced engineering of artificial intelligence. But simple things, gradients are used everywhere, even in decomposition, in optimization, not in deconvolution. Deconvolution is to find out components. to find out deconvolve means to find components out of a complex function, out of a complex behavior. So we want to deconvolve the behavior of deep models in order to understand the specific parts of their behavior. Similar is decomposition, and for decomposition we have several methods. Actually, all methods are based on the differences, on tracking the differences. Even so, gradients is the omnipotent factor analysis in every behavior of such models. So we involve one major methodology is LRP, is layer-wise propagation, layer-wise relevant propagation of gradients, and not only of gradients, of information layer by layer. A deep Taylor decomposition, you know Taylor series expansion, deep Taylor decomposition is based on such concepts. So actually, decomposition means we interpret things as functions, and we try to decompose the functions based on their gradients as Taylor expansion series in mathematics. I will not stay more. These methods are used, these are recent methods after 2013 and 15, and they are used mainly in computer vision. It's difficult for other, let's say, fields like natural language processing for reinforcement learning like ChatGPT models. But in order to have a small understanding, not a big understanding, you can see the inputs, images, you can see here. You can see their gradients. Gradients means to find the differences in the images about neighboring pixels. So you analyze the differences between intensities in the image, and you see a vague image here because these are differences, and you can see these differences. But you can see also with the different methodologies, these are only gradients, like edges. So you cannot see much because you see only the edges, only the differences. But you can see also the deconvnet, the deconvolution-based network. You can see more things here. Guided backpropagation. Backpropagation is a model of machine learning. You can see a better analysis here. You can see the pattern net based on patterns analysis, deep Taylor expansion here, and so on. And of course, the questions arise. You see the big pictures or no here. And let's see what happens actually with interpretability and post-model explanations. What we want actually is to have the things understood by people. So human-friendly concepts in our explanations. All these methodologies give results, of course. But can we answer questions like, okay, I have, let's say, stripes here. And in zebra, I have stripes. If I have stripes, can I have a zebra? Can I predict that the thing with stripes is a zebra? This is pattern analysis. The humans know very well, but the machines, you understand, algorithms, they don't understand such things. So, although we have invested a lot in explainability, up to now, we have only complicated black boxes. And tell me something honestly. Do you understand these things as a human? Look carefully. Do you understand patterns here? I personally cannot understand. I see the similarity applying these algorithms between some concepts, let's say, from here, you see here, but okay, and what is this? Are we doing the same thing in human brain? I bet no. We are not in the right track. We are not now, as we are, with such results, we are far away from explaining things. So still black boxes. And you see here, applying such deconvolution or decomposition, you can see the test image, and you can see here, okay, why this is a Siberian, why this is evidence, no, sorry, why this is evidence that I can explain more than this picture. I understand this picture. I don't understand very well what happens this. So explainability is something very difficult to be achieved. Our framework for responsible AI is far, far from being successful. In order to conclude, we have also many issues, as I tried to say, about accountability that is used for debugging. So troubleshooting the models, is it possible? Okay, thousands of engineers nowadays are in Google, in OpenAI, for Copilot, of course, in Microsoft, and so many engineers try to understand what happens with the model. So we have certain actually models like Compass and Corels in order to debug. The Compass is using many, let's say, patterns, more than 130 factors, like black box. It's black box-based debugging, but we have the Corels also, which is a similar analysis. But how to explain, for instance, from the Corels algorithm, in order to predict behavior, based on age, if you are between 18 and 20, let's say the models, and you are a male, then predict you will be arrested, of course, with some probability. You will be in jail. Also, if you are in these ages and with 2-3 prior offenses, not in jail, but you have a record, a criminal record, then predict arrest for sure. The previous was within 2 years. So male and young, arresting, bullshit. Else if more than 3 priors, then predict arrest for sure. Else, predict no arrest. So it seems that everything comes only from age, from gender, and from offenses. No other factors. This is bullshit. You understand that debugging of such rules, it's not so easy. Actually, we have black box, and all these methodologies do not lead to many, many good interpretations. So finishing, can we, with such black boxes, uncover hidden patterns, and how? Can we do this in computer vision? It's a good starting point, computer vision, because we see in computer vision. Here, in such cases, with trying to build an expert system, it's impossible how to understand how the system is thinking. But in computer vision, with the complex patterns that we can see even, we could understand something about how the system behaves. Although I have several here case studies, I think I exceeded my time a lot. So unfortunately, I have to stop here, telling you that there are certain case studies only. I have finished with the majority of things, but the message is to be able to contextualize, so within the context, to contextualize interpretability in a flexible and a robust way, understanding the hidden patterns. Here you can see the implicit patterns, here exactly. So based on hidden patterns and analyzing the hidden patterns, contextualizing them, we might be able to build interpretability. And of course, based on interpretability, then debugging the systems, we can debug the systems in order to ensure fairness, transparency, privacy, causality, and all the things that we mentioned in this framework. So thank you very much for your attention in this technical session, which is, again, not quantitative only, it's also qualitative. So here we have an example of big qualitative and the biggest, immense quantitative type of research. Thank you very much for your attention.